Hey, welcome back to these videos on math. Today we're going to be talking about combinations and what they are. In our last video we looked at permutations and found that permutations were arrangements of objects where order was important. In combinations, I guess they're not arrangements, but they're selections from a group of things where order is not important. It doesn't matter what order they come in. For example, say you're looking to win the lottery, and here are the numbers that you pick. Now, when the balls come up or whatever they do on the lottery, it doesn't matter if you get a 47 first or a 33 first. It's just that those numbers occur there. So it doesn't matter what order they come in as long as they're present. Same thing in cards. If you get a queen first, then a 10, then an ace, it doesn't matter the order. You could get the ace first, then the 10, then the queen. It's still the same hand. You still have an ace, a queen, and a 10. So the order doesn't matter. One example of that's sort of funny, this thing here typically we call a combination lock. But actually, combination lock order is important. So maybe we should call it a permutation lock. Anyway, here's our definition. Combination refers to the number of different selections that can be made from a larger set where order is not important. So it doesn't matter, like here it would matter, but things like if you're get a hand. So the order that these come in doesn't matter. Okay, so for example, let's try a question. I've got 5 letters, and from those I want to select 3 or choose 3. So the question is, how many 3-letter combinations can I get from that? And maybe when we're finished with that, we can compare that with how many 3-letter permutations. So here's a table from the book. They indicate that here are the different combinations, here are the permutations. So notice that the combination of getting an A, B, and C is one thing. Whereas a permutation, you could have it in this order or that order or this. There's 6 different orders you could get it in. So there's 6 different permutations with the same 3 letters. But in combination, it's just one thing. It's an A, B, and a C. Doesn't matter what order they come in. Now, formula for combinations, similar to permutations. Remember, we had n pick k or n pick r. That's a PR. Combination formula is similar to that, where n stands for the total number of objects that you have, and k or r, depends on your book, is how many you are selecting. Okay. Now, also look for this button on your calculator, N choose K, or typically the calculators have an R on it. Look for that button, and that's the one that will help you determine how many combinations there are in a particular example. You can try these on your calculator if you want. Here's the formula too that you can use to determine it. Okay, so 11 choose 3 would be, just using the formula, 11 factorial over 3 factorial, and then 11 minus 3, or 8 factorial. Remember, factorial means 11 times 10 times 9 times 8, etc. And on the bottom I've got 3 times 2 times 1 times 8 factorial. The 8 factorials will be a factor of 1. I can eliminate those. Maybe I can simplify this a bit more. 3 goes into 9 3 times, and 2 goes into 10 5 times. So now it's 5 times 3 is 15. 15 times 11, about 165. On your calculator, you probably already have that. Here's an example of one, though. I've got 49 total balls, and for the lotto, we're choosing 6 of them. Again, the order that they come in doesn't matter, it's just as long as they get there. So if I wanted to figure out how many different ways that could happen, how many combinations there would be, it'd be 49 total balls, and from those I'm choosing 6. In the question here it says, what if you bought every combination that you could from the lottery, and so for sure you'd win, would you have paid too much money? So 49 choose 6, I'm not sure what it comes out to, but it's in the millions of different combinations that come from 49 balls and choosing 6 of them. And if your ticket costs $2 each, you do this on your calculator, then just times it by 2, and that'll tell you the total amount of money you'd have to spend in order to for sure win. I guess one of the problems would be is if somebody else had the same combination of numbers, and you'd have to split your prize. Here's another example. How many ways could you group 30 students? So I have 30 total students, and I'm grouping them into threes. Notice the order doesn't matter. Like if I made one person president, a vice president, and a treasurer, then the order that I choose them makes a difference. That would be a permutation. But if order doesn't matter, 30 choose 3. And you can do that on your calculator. Here's an interesting question where I've got a couple things happening. I've got a committee, and it has to be an equal number of men and women. So I have to have 6 members, and I have to have the same number of men and women. So I have to have, well, if there's 6 people, I need 3 men and 3 women. But then they say I have 7 women to choose from and 8 men to choose from. So how many committees? Well, here I can use the same idea. I've got 7 women, and from them I'm wanting to choose 3. Doesn't matter the order that they come in. Also, I have 8 men, and I want to choose 3 of them. And then according to the fundamental counting principle, it says figure out the total number of ways of doing one event, find out the total ways of doing the other event, and then multiply them. So if you do 7 choose 3 times 8 choose 3, you'll get your answer for that question. Another example, Texas Hold'em cards dealt, 2 cards are dealt to each player. How many different hands could a player receive if they just have 2 cards? So there's 52 cards in a deck, and from them I'm choosing 2. So if I do that on my calculator, that'll tell me how many different hands I could have. Okay, hopefully that gives you a little bit of help with combinations.